Okay, now this is the last stop where we're going to be taking some measurements. It's also the last stop I want to say anything about what's happened to the river. Now, we were in a gorge, all of what, 500 yards, even less than that, probably 200 yards ago, 300 yards ago. And yet very suddenly we're out into something different again. If you have a look around here, this is something that we haven't seen before. What's happened to the valley now? It's got a flattened bottom. Well, when I say flat, I think in micro detail we can't really call it flat. We'll come back to that. But we still got very flat, very steep sides. You might describe it as U-shaped. I don't want to get confused though with glaciation in terms of glacial landforms. We would describe a valley as U-shaped, but it is sort of U-shaped. You've got quite steep sides both sides, and then a flattish. I'm not going to go with the idea that it's flat for reasons we'll discuss in a minute. It's the valley floor though that I'm interested in now. In detail, it's anything but flat, because it's got these weird and wonderful little shapes in it. This one particularly looks like we've got a circular shape around a central circular hill, which is a bit strange. We're already getting a suggestion here. Excellent. What did you just say?
Meander scar.
Yeah, it's like a meander scar. Now that's a very nice technical term. What do you actually mean by that?
It's where the river used to flow,
It found a shorter route, and so it dried up.
Right, okay. So what we're talking about here is a floodplain that a river was meandering over. Now I would accept a meander here, that we've got a river that seems to have chosen to go in a very winding route. Up there it was sort of finding its way around things, not having seemingly a lot of choice in the matter. Here we have got a floodplain with, we can imagine a former route of this stream was here, and it was flowing around there, and in the middle there was a sort of remnant of so I suppose you could also call it the eye of a meander, you know, the middle of the meander. And there was sort of a neck of a meander here, and the stream went around there. But normally in a floodplain, what type of erosion are we talking about? Lateral. We're talking about lateral erosion around the outside bend of meanders, and as a result meanders migrate across a floodplain, and you're quite right, they may leave a mark where they've been, and you sometimes see those in the form of an oxbow lake. Have you done oxbow lakes? You come across oxbow lakes, and if an oxbow lake dries out, then that might leave a scar or a slight sort of dip in a floodplain where it used to be. I think we got more than that here. I think we've got the start of the answer. We've certainly got a floodplain. If you see on the outside of that bend there, the outside of this bend there, this is certainly deposited material. So it's not like we saw up there where we had the first signs of lateral erosion, but it was still pretty solid rock we were talking about. This has been deposited. It's a deposited floodplain. Meanders have meandered across it, and there has been lateral erosion around a meander, but something else has happened, and it links to what we were saying at the last place. I didn't hear what that was said. Did you? Incised. Yeah. Exactly. But what we've got here is, if the river's been rejuvenated up there, then this has been rejuvenated. There it was rejuvenating itself into a V-shaped valley, so we end up with a V and a V. Here it's rejuvenated itself into a floodplain. So it's eroded material that it's previously deposited. And as it's eroding, and it was a meander, we can assume that this was meandering a bit like it is now. So not only was it eroding down around the outside of the meanders, it was eroding sideways, so it'd be lateral and vertical erosion. And it cut away into its old floodplain. And you can sort of spot various heights of the old floodplain. A flat section, an old floodplain. Another flat section, an old floodplain. You could even say that there's a flat section, another level of the floodplain. Because as it was eroding down, it was also eroding sideways. And it left behind remnants of the old floodplain. So all the way looking down there, you can sort of see level bits of an old floodplain. And what do we call the remnants of floodplains? Terraces. Excellent. So these are classic examples of terraces resulting from rejuvenation. Admitted that we haven't got much of a floodplain here. It's what, 40 yards wide, if that. It hardly comes out as a floodplain if you're looking at the map. I reckon that we are at grid reference 437,927. At first glance, you would hardly say, if you were just looking at the map, that there was a flat valley floor here. If you look closely, you can just about make out a gap in the contours. It still looks like an upland stream. But here we can see, you can just about make it out on a good photograph. If you were trying to show the levels, we could even draw a field sketch here. Difficult, but you could show the levels of the different steps in the terraces and the old channels like this. You can certainly see an old channel between the two bits there. And it's the result of two processes. A meander, not only laterally eroding, which we'd expect on a floodplain, but also being rejuvenated and cutting down. They're called incised meanders, and they can produce, in this context, terraces, like we're looking at here. And that's the point of this particular stop from our descriptive, our qualitative description of this valley, which we could back up with some field sketches labelled to show these features. Understanding all that may help us interpret all this quantitative stuff. Are what we're saying about these valleys changing reflected in the figures that we're collecting about what the channel's up to? That'll be interesting for you to discover when you do look at your statistics. And that's also a point about where we've done our data collection. Where did we choose to take our data collection points? Why did we stop where we stopped? Any suggestions? We're stopping here. Yeah, where there is a difference, where something's changed. Now, a scientist may not be too pleased with that idea of sampling. Just take your sample where something's changed. A scientist might say you've got to be a bit more scientific and you've got to do it every 200 metres or whatever you decide on your journey down. Now that might be worth a discussion between a scientist and a geographer. Geographer might say, yeah, but we would have totally missed the nick point, or we would have totally missed the floodplain or whatever. So an interesting discussion in terms of, well, what are we trying to do on this geography trip? Scientists might say to the geographer, yeah, but doing it your way, you'll prove whatever you want. You'll just take the measurements where you want to prove what you want to prove. So that could be a discussion you could talk about in terms of advantages and disadvantages of the methods that we've used. Certainly from my point of view as your geography teacher, I wanted to point out these changes of the valley as we went down. Whether that's the right thing with regard to actually the points where you take your measurements is another story. Okay, well, as suggested, there's now the measurements here. What about the measurements? What about the gradients in this floodplain terraced area? Whose was the map?